Welcome, folks. You have gone to an interview in a MNC company or some MANG company. MANG stands for this Meta, Amazon, Apple, Google, Netflix. Right? So they asked you to design a messaging application like WhatsApp. How do we design such a system? Let's get into the details of it now. So in this video, what I'm going to cover is what are the functional requirements, non-functional requirements that we need to discuss for this WhatsApp, capacity estimations, data modeling design, followed by API design, then we'll go to the actual high-level system design, then scaling the design, and then we'll discuss the trade-offs. Ideally, this is the right order that you need to follow for any of your system design interviews at big companies. Before we get into the details, I recommend you subscribe to the channel, press on that bell icon so that you don't miss the coming videos. At the same time, like and comment this video. Ideally, as mentioned, this is the preferred order you need to follow in your MNC companies interviews for system design. In fact, for any companies for that matter. First of all, what is WhatsApp, right? It's a chat application that allows instant messaging functionality. So it's one of the most used mobile applications on the planet, as we all are aware. So it's connecting 2 billion plus users in 175 plus countries. So it's huge, right? If we have to build such a system, what is that we need to do? Let's get into the details. First, once you get in interviews, first you need to start writing the functional requirements based on the design or the based on the problem statement they had given you, right? Let's start with the functional requirements. So what is it? It should support one-on-one chat, right? Next, it also should support group chat. It should support some file sharing, right? Like text, images, videos. It should support the file sharing like text, images, and videos, as we normally, share these kind of files in any of the chat applications. What other thing it should show? The read receipt, right? The ticks that we get for send, delivered, read. Single tick, double tick, and blue tick. Single tick means it is sent, delivered is double tick, and red is blue tick. So similar to that, it should show a read receipt. Then it should also show the last seen time of the users, right? So these are the functional requirements that we, mentioned here in for this WhatsApp system design. You can go and cross check with your interviewer. Is this sufficient, or are they expecting anything more from this interview? Once that is done, we can, mention to the interviewer, I'm moving to the non-functional requirements, and you can start writing your non-functional requirements. So low latency, right? We need to have very low latency as the chat application needs to be real time, right? While you are sending the message, immediately the other person should be able to see the message. That's the basic requirement. So hence low latency is one of the primary non-functional requirements that we need to consider. Next, high availability. So system should be highly available. The system shouldn't go down at any situation. So while you're writing these during your system design interviews, either on a whiteboard or virtually, you need to keep talking to your interviewer. That is more important. Your thought process, how you're thinking about each of the factors that you are chiming into these systems, should be very clear to the interviewer, right? Next is scalability. So WhatsApp has almost millions of users across the world, out of which, millions and millions of monthly active users and other things. So scalability should be another primary factor that you need to consider when uh, discussing about the non-functional requirements of the system. Once you're done with these non-functional requirements definition, you need to check once again with your interviewer if he is okay with these requirements, or if anything he or she thinks needs to be added either in functional or non-functional requirements, and have this agreement with him or her before you proceed to the next section. Is it clear? Next is about capacity estimations, right? Actually, this video is getting longer because I wanted to discuss about how the capacity estimations IDT are done. Since this is my first system design interview video, I thought let me explain this concept in this video. Maybe in the coming videos, I'll not get into this much detail. So apologies for the length of the video upfront. Right. Capacity estimations, some basics. That's what I want to cover now since this is the first system design interview from my side. Either you remember or try to understand this and keep in mind how, while doing capacity estimations like this, right? 10 power 3 is kb. It's equivalent to 1000. Remember this. 10 power 6 is 1 MB equal to million, right? 10 power 9, 1 GB equal to billion. 10 power 12 equals to 1 TB equals to trillion. And 10 power 15 equals to 1 petabyte, right? Equals to quadrillion. Try to remember these, at least till trillion. It will help you. And another basic factor that you need to, go to know as while you do these computations is day to seconds, right? We are having 24 hours in a day. Every hour has 60 minutes and every minute has 60 seconds equals to 24 into 3600, right? So remember, we are doing this capacity estimations. These are not real calculations. So these are estimations. No one expects you to be kind of very precise or anything here, since these are estimations. So you can have some liberty here to make it simple, right? So here you can take this as 25 into 4000, if you round off things. So which is equivalent to around 10 power 5. You can remember this as well. Let's assume the traffic now for the WhatsApp, right? Let's assume DAU is daily active users equal to some around 50 million, right? And also assume each user sends 10 messages to around 4 unique users per day. So which is equivalent to 50 million to 40 messages, right? Which is 50 into 10 power 6 into 4 into, 40 messages, right? 1 to 10, which is equivalent to. Also, please comment if you really need this level of details or am I going into too much of details. So this is like 200 into 10 power 7, which is 2 into 10 power 9, which is equivalent to 2 billion messages per day, right? So this is the daily messages per day, which means 2 billion requests per day, which translates to what? We want to convert this to per second. 2 billion by, if we have to convert it to, 24 by 3600, right, per second, it's equivalent to 2 into 10 power 9 divided by If you remember earlier, we have computed this per day. It's coming to 10 power 5. Just, you can see day to seconds, a couple of minutes prior to this. So, which this translates down to around 20,000 requests per second, right? So, this is a we are going to have 20,000 requests per second if we assume the daily active users of 50 million who sends 10 messages to 4 unique users per day. Also, out of this, we also given the requirement that we'll also support the videos, images, and other file types here and not just text messages. So if we assume 10% of this traffic is files such as images, videos, etc. So how many would be the file transfers here? So 10% of 2 billion, right? 2 billion is equivalent to what? 200 million per day. So we'll be having uh, this is what file transfers, right? This is the estimation for file transfers. Now let's move to some storage estimations, right? So you can ask your interviewer here. You can mention I'm done with the traffic estimations. I'm trying to move to the storage estimations. If the interviewer is fine, you can go ahead and start the storage estimations. Let's here assume on average each message is 100 bytes, right? Each message is 100 bytes. This assumptions, while doing the system interviews, you need to make few assumptions, right? So the interviewer would be expecting it, and if they are not in alignment with what you are assuming, they will call out immediately. No, no, don't take 100 bytes, take 200 bytes or take 50 bytes. I don't think they'll get into that level, but it's always better to call out your assumptions, right? So one message is 100 bytes. How much it will be for your billion messages? 2 billion messages. So 2 billion into 100 bytes, right? Which is equivalent to around 200 GB per day. Right? So as per our requirements, we also know that 10% of this traffic are our media files, which are images, videos, or any other files, right? That users will share on this platform. Let's assume here for files, 100 KB is the average file size. Moving with this assumption, we got that file transfers would be 200 million per day. If you see the above, our computation, 200 million file transfers is what we are going to have per day, right? So 200 million into 100 KB, right? KB, as we saw, it's 10 power 3, right? You see the above computations, you will know. So 200 into 10 power 6 million you have seen already. Its million is 10 power 6, and now it's 10 power 5. 100 into 10 power 3 is. So overall it's 2 into 10 power 13, which is equivalent to 20 TB per day. We, based on our assumptions, with 10% of traffic being the file transfers, with each file on average having 100 KB of data, then we need 20 terabytes per day for file transfers. Whereas for messages, with 2 billion messages and 100 bytes per message, we need 200 GB per day, right? If this is the case for 10 years, how much we require? The capacity needed is 10 into 365 days into 20 TB equivalent to, you can round it off things as these are estimations. 400 into 20 equals to how much? 8 into 10 power 4 into 10 power 12 is almost like 80 petabytes. So for 10 years, we need 80 petabytes of storage needed to have these file sharing working at 100 KB per average file size with 200 million, file transfers happening per day. Hope this is clear till here. So you check with your interviewer again here if he's okay, he or she is okay, and move on to the next section. If you are finding this video useful, go ahead and subscribe to the channel. Also like the video and comment as well if this is helping you in any way. Let's move on to the data model design. Before we get into the data model designing or database designing, you can discuss this with your interviewer on what are the choices you are thinking here for your database design for this particular problem. So we can use a combination of relational and distributed NoSQL databases. So we can use the relational databases like PostgreSQL for storing user information, and we can use a object store like AWS S3 simple storage service to store the media files like images, videos, GIF files, any similar files, right? After this, you can start designing your database. I'm going to have a user table first. So this table actually will contain user information such as a name, phone number, and other details of the user. You can quickly design few tables and show to your interviewer, and then you can move on to the next section. So user ID can be UUID, and you can have the username, and you can also have the user phone number in this table. So moving on to the next table, which can be a messages table, right? What does a messages table can contain? ID, which is again UID, and your user ID, group ID, user group ID, right? Chat ID, your type, content of the message, when is it sent, so when is it delivered, and when is it seen, right? When is it seen? So these all can be timestamps. I'm not writing for every type of it for every parameter here. I hope this is understandable. So timestamp for these type can be an enum here. What is type of the message, and chat ID? These all can be UIDs, and content can be a string. Or then let's quickly have a groups table. So group ID, which is again UID, and you can have a group name. Right? You can have a chats table, chat ID, which is again UID, and here chat, name of the chat. So you can have another user chat table, which is containing the IDs for user chat, and also it references the user ID and chat ID. Similarly, you can also have another user group. So where you have ID of the user and user ID, which again a UUID and group ID. So you can design all these data modeling designs, right? Where for the especially the primary ones, user, messages, groups. So messages table, as you can see, containing all these message details of message type, related user group information, timestamps for delivery. So and also corresponding chat ID or group ID, and user chats table mapping users and chats as multiple users can have multiple chats. This is like N is to M kind of a relationship here, right? Once you're done with this data modeling design, and your design choices, you can go ahead and move on to the API design. Hardly we are going to get 45 minutes to 1 hour for this system design. So you need to also manage your time effectively while you are doing the design. Moving on to the API design, just discuss with your interviewer and move to the next API design. So I would like to have a joint group method where a user should be able to join to a specific group, and it returns if it's success or no. And exit group, and it takes user ID and group ID. It returns back the status of whether it's successful or not. Get chat. You want specific chat for a specific user. Actually, we can have this as a chats for the specific user, right? We can get the complete set of chats for this user. Get groups of user. What all groups this user is part of. We can pass the user ID and we will get back the group IDs. We can have get messages of this particular user and takes user ID, group ID, and what we get back is all the messages or chats for this particular user for this particular group. You can also send a message, user ID, group ID, and a message, which is a type of a message. And we'll get back the status of it. So after designing these APIs, you can check with your interviewer again if he or she is good with this API design or if they are looking for any other specific API functionalities. If so, you can add those as per the need and as per the discussion and how it goes. Since the video is getting longer, I have drawn the system design and let's discuss this. Normally, for any system design interview questions related to real-time communication, we need to use WebSockets because WebSockets is the communication protocol that establishes a persistent two-way connection between a client like a web browser client, mobile application, and a server, allowing for a real-time low latency data exchanges. Also, with real-time messaging, we can either use pull model or push model. In the pull model, the client can periodically send an HTTP request to servers to check if there are any new messages. Pull model is not that much scalable due to its overhead on servers, whereas in the push model, the client opens a long-lived connection with the server, and once new data is available, it will be pushed to the client. So WebSockets are used for this, which we are going to use in this chat service as well. In this design, we are using the microservices architecture. Let's see some of the services and their usage. Clients connect from the various devices across the globe. We have load balancers in front of the system to handle the traffic. WebSocket Handler is the backend service which keeps connections open using WebSockets for all the active users. These are the live users having the active internet connection. User service is the service that handles user authentication, authorization, and handles the user information connected to the user DB, which is a relational database. The chat service internally using the WebSockets to handle the real-time communication and to establish connections with the users to handle one-on-one chat functionality, whereas group service similar to chat service but handles the group chat delivery functionality. So these chat services also maintains the details of which device is connected to which one. This data needs to be stored somewhere where we are using a cache here, could be Redis to store that information. For example, WebSocket handler 1 is connected to users 1, 2, 3 up to n, and that information is stored in this cache. And if the handler is updated to Another instance of WebSocket handler, say WebSocket handler 2, this info will get updated in the cache. Chat service have access to the repository of messages which can serve the get message, get chat by user ID, get messages by message ID kind of API. So it sits on top of a database with all the messages information. It could be a Cassandra database which can handle this heavy load of billions of messages well. Media services used to handle the media like images, videos, files, and similar any kind of files, right? File types. The media is stored into an object store like Amazon S3. There is also CDN attached to media service where frequently accessed media is put there. For example, there is some huge political or entertainment event happening and everyone sharing same images in the groups and videos, so those can be put into a CDN for faster access. The notification service is used to push the notification to the users. Last seen service handles the user's presence and updates the last seen info. Group messaging, the messages are put into Kafka topic and the group messages handler reads it and delivers the messages, whereas the users who are not active, messages will be stored in the DB till users are online next time and deliver messages accordingly. The read receipts are updated back to the clients using the WebSocket handler based on the status of the message delivery. Though this is slightly tricky for this use case, we can wait for some sort of acknowledgement from the client to determine if the message was delivered and update the corresponding delivered at field that we defined in the database message table. Similarly, we'll mark the message as seen once the user opens the chat and updates the corresponding seen at timestamp field, whereas the last seen service will keep track of the last seen status of all the users and updates back to clients. We also have data analytics service which can read the Kafka topics and perform some data analytics on a Hadoop and Spark clusters for data analysis. This is the overall high level system design for the WhatsApp or any messaging application that you can think of that you can discuss in your interview, right? For scaling, we can have multiple instances of all these services with auto scaling enabled to handle the load, including the load balancer. For database scaling, we can partition the data by horizontal partitioning or sharding. We already have caching CDN enabled here, especially for group messages and media files where multiple users requesting the same media files and messages. So to prevent traffic spikes, we can cache these messages, and also if media involved, we can store them in CDN for faster access across the globe. If we come to some trade-offs here, we can improve the system by having an API gateway in front of the load balancer and move the authentication and authorization logic from user service to API gateway. This way, instead of going to the backend services, API gateway can perform the needed authentication and authorization itself. It can help also in rate limiting, throttling, ensure some group chats or clients not crossing the set limits. This will overall improve the quality of the system, right? So this is the high level design. Based on the discussions how it's going through within your interview, you can add some more trade-offs, some more scaling discussions as well based on how your discussions with interviewer is ongoing, right? So hope this video helped you. If so, like the video, share to the people who might need this, and comment if you want us to do any other specific content. Also, we are really putting a lot of effort into this. If you recognize it, please go ahead and subscribe to the channel. Thank you.